Welcome everyone to meetup number 58. All right, we're getting pretty serious with this data on Kubernetes thing. We're having lots of meetups. This is meetup number 3 of this week. This is the second meetup we're doing this week with someone from Italy. Yesterday we had Enrico, who is in Rimini, that I found out is kind of like the unofficial or official gelato capital of Italy. They have a really big trade fair. But today we're joined by another Italian person who really embodies the spirit of what we're going for here as a community in 2 different ways. A, because what he's going to be talking about is working with databases and stateful workloads on Kubernetes. B, is that he's really embodying our community spirit of being resilient, not just in the data resilient sense, but as a person, because of having to improvise. Gabriele is supposed to be joined by Francesco, who can hopefully join us. Francesco had a little bit of an unexpected situation come up, so we're hoping that he'll be with us later. But like I said, Gabriele is no stranger to data on Kubernetes. Been working with databases, data issues for quite some time, and is currently doing so at EDB. Gabriele, welcome to the Data on Kubernetes meetup. As usual, for everyone out there, you can follow us, subscribe on YouTube, Twitter, LinkedIn. We're in lots of places. Get in our Slack. We've already agreed that in terms of questions, you can put your questions in the chat, and we will try to get to them at the end. But Gabriele's got quite a few things that he wants to cover in his presentation, so we're just going to leave him to it. That being said, Gabriele, welcome to the Data on Kubernetes community.
Thank you, Bart. Thanks for the nice and warm welcome. And yeah, it's exciting for me to be here. So
very good.
Yeah, thank you.
Good. And you are also an AC/DC fan. Can we ask you what's your favorite AC/DC song before we start?
It's A Long Way to the Top.
Oh my gosh, very good choice. Love the bagpipes. Love the bagpipes. Wonderful song. It's a really motivational song. That's a really, really good one. That's good. That being said, I think we're all motivated, getting ready to go. We're already getting some nice comments in YouTube from some of our other Postgres friends. Postgres is a very attractive topic. Why is it so attractive, Gabriele?
I don't know, because it's like, I don't know, one of those things that never fades away. I mean, it's survived to, it's dynamically changing, you know, continuously changing, you know. There's new technologies and PostgreSQL adapts all the time, thanks to extensibility, in my opinion.
Okay. No, I think it's a good point. And also, like, you know, being battle tested, you know, it kind of matches up well with that song. It's a long way to the top if you want to rock and roll, you know. Yeah. Postgres has been around for quite a while. It's had, like you said, has had iterations with different technological changes over time. But just as interesting as a community, the meetups that we have that involve Postgres generally attract a lot of attention, and yours is no exception. We had really good feedback in LinkedIn, lots of wonderful support too from the other folks at EDB. Thank you all very much. That being said, Gabriele, you can jump right into your presentation if you want to share your screen. Just as a reminder to all the folks in the audience, put your questions in the chat. We will get to them at the end. We will leave time at the end to get those going. Or if not, you can tweet them. We can get them in Slack. We will get to your questions, but we want to allow Gabriele as much time as possible to get into his presentation. So that being said, Gabriele, whenever you want, you can just share your screen. We can jump right into it.
So 1 second.
Yep, no problem. Very, very good. Like I said, this is meetup number 3 this week, so we've had a lot of data on Kubernetes energy, and that's a perfect question to start out with. I love it. All right, I'm going to be quiet. It's all you now. Go for it.
Thanks, Bart. So why and how should I run database on Kubernetes? And why should I use Postgres as my database technology? Why should I benchmark my databases before production? So I'm sure that you have been asking yourself either one or more of the previous questions if you use Kubernetes and you are at least curious to use Postgres in a cloud-native fashion. So welcome to the 58th webinar of the Data on Kubernetes community. Tonight I will be talking with my colleague Francesco, if he comes back on time, about why benchmarking Postgres in Kubernetes is important, and introducing a new open source set of guidelines to help you with that process. So please let me introduce myself quickly. My name is Gabriele Bartolini, and as Bart mentioned before, I live in Italy in a city called Prato, which is the second largest city in Tuscany after Florence. It's actually the city that hosted the first ever PostgreSQL community conference in Europe back in 2007. I've been using Postgres for almost 20 years now, and I've been a member of the community for the last 15. I'm extremely proud to be one of the 4 founding members of Postgres Europe, which is the associations that organizes the European conference, Postgres conference. I've been working with Second Quadrant since the start, and I've covered several roles, including CEO of the Italian and Australian branch, head of global support, and lead of the Cloud Native initiative. Since the acquisition of Second Quadrant, I'm part of EDB, where I lead the Cloud Native initiative as well. I'm also one of the founding members and contributors of Barman, which is a popular open source tool for backup and recovery in the Postgres space. I'm also a big fan of Lean, Agile, and DevOps disciplines and culture. So Francesco was supposed to be speaking today with me, but he had an unfortunately a last-minute personal emergency. So hopefully he'll be making it on time for his part of the presentation. Otherwise, I'll try and do my best to describe the actual work that he did with his team at EDB. So sorry for the noise, but my kids have come back from
That's part of the magic. That's not a problem. That's part of the magic. That's all good.
Francesco started to work in my team at Second Quadrant in 2013, and is an expert in several areas: Postgres, especially business continuity and monitoring, infrastructure and automation. And over the years, he's contributed to the growth of Second Quadrant automated testing posture, from the setup of CI/CD pipelines to all sort of test writing, from unit tests to acceptance tests, smoke tests, and so on. So always interested in containers technologies, become a very skilled engineer in Kubernetes with over 15 years of experience in Kubernetes. Hey, I'm just kidding. 15 years in Kubernetes. I see it sometimes in our CV. So in his spare time, Francesco is a karate instructor. So that's why we call him our sensei. I'm a big Cobra Kai fan, by the way. So here's the agenda for today's session. I'll go through the why questions that I asked at the start of the presentation. Then I'll try and present the context in which our initiatives took place. I'll try and provide my view on why benchmarking the storage for a database workload in Postgres is important before benchmarking the database. Then introduce our open source project called Pgbench and share some results before the end. So let's start with the whys, which is always good in my opinion. So the first question I asked at the start of this presentation was, why and how should I run a database on Kubernetes? So one important consideration here, I don't think I should go into much detail on the benefits of using Kubernetes with this audience. Okay, I think we all know what Kubernetes is and the problems it tries to solve. But I'll try and describe my opinion, which might differ from yours, and that's fine. That's why we like to work to be active in a community. So in my opinion, one of the advantages of Kubernetes is both the culture and the ecosystem where Kubernetes developed and nourished. At the end of the day, Kubernetes is just a tool, and it might even be superseded by another tool in the future, who knows? But what matters and what is important, in my opinion, is the cloud native aspect of Kubernetes. So, and with cloud native, I essentially mean three things. The first one is a DevOps-based culture, which enables teams and organizations as team of teams to continuously change, so to innovate and accelerate the delivery of outcomes that produce value for the business in a safer, more efficient, and more engaging way. The second one is a microservice architecture that is based on containers. And the third one is a way to manage and orchestrate these containers using, for example, Kubernetes. So this is not the occasion to talk specifically about DevOps, Lean, Agile, and so on, but always feel free to ping me, even in the Data on Kubernetes chat, if you want to share your experiences with me. So in a microservice architecture, the microservice should own the data that it manages and own it in an exclusive way. This could be, flat files, queues, key value stores, or in the case of Postgres, a relational database with both structured and unstructured data. Only the microservice can access the database, including schema management and migrations. I think this would be the ideal, scenario. We should also anticipate the inevitable consequences of Conway's law by leveraging microservices and organizing our products and systems in general, considering the boundaries of each team's cognitive load. And with cognitive load, I like to use the definition by Dan North. It's the software that fits in our head. Okay, so beyond that, as human beings, we cannot operate efficiently. Okay, so as a result, design loosely coupled microservice-based systems with clear boundaries defined by their APIs. So all of the above concepts, they all resonate with me, okay? So they are the reason why I believe that databases can logically fit well in a cloud-native environment that is based on Kubernetes, where everything is a workload, databases included, okay? So by owning the databases, applications can be, for example, easily tested in CI/CD pipelines that are designed for containers distributions and continuous delivery of software. So if you want to know more about this story, please scan the QR code to read a blog article that I recently wrote. So this is an example of a microservice application with its own Postgres backend in a Kubernetes cluster that talks to another application with another Postgres backend in another Kubernetes cluster via defined REST API in this case. So each of them owns their own database and data store, okay, using Postgres. So now we need, now that we talked about why databases can fit in Kubernetes, as a long-time community member and contributor of Postgres, I'd like to talk about why we should be using Postgres even in Kubernetes. So let me spend a few slides on Postgres for those of you who are not familiar with it. So Postgres, for the third year in the last 4, has been voted as the best database by DBEngine. And when we talk about PostgreSQL, or as Bart did, for the presentation of this talk, Postgres, PostgreSQL, all the variations, people call it the way they want, but it should actually be PostgreSQL or Postgres. It's one of the most successful open source projects in human history. Okay, so that's what we're talking about here. Okay, so I'll try and recap in a single slide decades of development of Postgres, and based on my experience and opinion, I'll try and select the most remarkable features of Postgres. So forgive me if I'm missing your favorite ones, okay? A quick way to describe for me Postgres is that it is the equivalent in the database area of what Linux represents in the operating system space. So the current latest major version of Postgres is version 13, which ships out of the box native streaming replication, both physical and logical, and the details are in the next slide. Continuous hot backup and point-in-time recovery, declarative partitioning for horizontal table partitioning, which is a technique to improve vertical scalability on a single instance. JSON support, which enables the multimodal hybrid database, holding both structured and relational, so structured, relational, and unstructured data to be queried and stored in the same database using SQL. Then extensibility with extensions like PostGIS for geographical databases, parallel queries for vertical scalability, and so on. So in terms of architecture, Postgres natively supports the primary standby architecture with optional and multiple replicas. The technology behind replication is very robust. So it's just the evolution of crash recovery and point-in-time recovery technologies, which were first introduced in PostgreSQL 8.2 about 15 years ago through wall shipping and war standby, and then later improved in Postgres 9.0 through wall streaming and read-only replicas with hot standby. So further improvements include synchronous replication, which enables RPO 0 clusters and backups, so zero data loss clusters, and cascading replication, which means replicating from a standby. The last one, the last kind of replication that PostgreSQL natively supports is logical replication. So considering that stream replication has been around for more than 10 years, the technology is very stable and robust and guarantees very high results in terms of business continuity, measured by recovery point objective and recovery time objective. Having said this, we can now explore how Postgres can be installed in Kubernetes. So there are basically two approaches. The first one is the basic approach to use self-healing capabilities of Kubernetes by having a pod running a Postgres container with no Postgres level replica. Okay, so replication and high availability is achieved through the storage. But we are actually interested in the second case. So in this talk from now on, I'll talk exclusively about the second case, which is using an operator to manage PostgreSQL. So by doing so, we are able to rely on PostgreSQL native replication. We are moving up replication from storage level to the operand and operator level. So when I mean operand, I mean Postgres. So the application in this case, the workload. This might represent an anti-pattern in Kubernetes, at least outside the data on Kubernetes community. So I expect that this community actually agrees, on application level replication in this case. So native Postgres replication brings us synchronous commit at transaction level, synchronous standby servers, cascading replication, and point-in-time recovery. Everything we need to ensure business continuity at database level, with the possibility to restore at any point in time from the first available continuous backup in the catalog. An important note here, I get that we might not be objective here, okay? But our team at EDB has been writing these features in Postgres for the last 15 years, okay? And continues refines them. Everything has also been validated by supporting our customers over the years on some of the largest databases in the world that rely on an open source database management system like Postgres. So our message here is strong, and that we want to bring Postgres everywhere. And Kubernetes is where we need to be and where we need to do more now. Okay, so that's our mission. So this is a non-exhaustive list of operators that are available for Postgres. There are some open source like Crunchies, Zalando, Postgres, KubeDB, and Kubegres. And I know that one of the next talks will be by Alvaro on Postgres. Oh, here is Francesco. Good to have you, Francesco. I hope you're fine.
Oh, hello, Francesco. Welcome.
Hi. I'm with less than I had a few hours ago, but
but you've acquired
and the packet of ice.
Yeah, you've acquired an ice packet and some patience and more resilience, and now you're even a stronger sensei, because I found out from Gabriele that you're a black belt in karate. That's amazing.
Yeah, but the dentist is Kubernetes, self-healing capabilities. Now the pod is.
Yeah, self-healing, auto-scaling, we've got everything. That's good. Anyway, Francesco, welcome to the Data on Kubernetes community.
Thank you.
There's a pod disruption budget as well, so make sure you don't. Sorry. Anyway, what I was saying is that there's also a closed source operator from EDB. So this is the only place where I'll mention this. It's called Cloud Native Postgres, and with a 30-day implicit trial license that you can use with the open source PostgreSQL, which I remember is where EDB is a major contributor in terms of code and developers. So we actually invest a lot in the Postgres system itself. Okay. So our goal at EDB is to exploit all the benefits of the cloud native world, which you all know, as I said, in this audience, with the best database in the world, which is Postgres. So it is important to note that to use Postgres on Kubernetes, you need a multidisciplinary team with skills on both Kubernetes and Postgres. Hence why I mentioned earlier the importance of DevOps, okay? It's not a coincidence. We need to master the whole system and know it well. Weak spots, strong points, and limits in general. So what's the best way to do this? So the answer is benchmarking. So Francesco and I come from a city in Tuscany, which is not far from Pisa. Pisa is where Galileo Galilei was born. So the scientific approach is imprinted on us, okay? It's part of who we are. Unfortunately, the whole team needs to continuously declare expectations, run experiments, measure the results, and compare them with the initial expectation. So over time, this approach has saved us several times, no matter the size of our organization, when we were small, larger, and so on, but also where the customers were, okay? It also allowed us to win over challenges that at times looked beyond our reach. So another important piece of advice is to try and move our focus from the technical means, so the tools or the way we've always done it, to the actual goals, which might force us to go down different paths to reach our goals and always ask why we are doing certain things. So my favorite ones, which were and still to some extent are recurring, I want rack in Postgres, which actually triggers the question, why? What is your goal in terms of recovery point objective or recovery time objective? Because Postgres doesn't have rack. There are other ways, other means to reach the goal. I want infinite horizontal scalability. So where the actual needs for example, the actual needs for horizontal scalability in terms of transaction per second. So I want to clarify that I'm not saying this because Postgres does not natively support query and data distribution, okay? If our results of benchmarks show that the observed transaction per second don't meet our real requirements on a single primary system, that's when we should look at different options, including horizontal scalability. So data distribution across different servers, different nodes, okay? Remember that simplicity is key when business continuity is involved. Keep your system simple is a fundamental rule that we've learned over the years. So finally, let your decision be driven by numbers and measurements rather than opinions, because everyone knows it should be done that way. Remember, every context is unique. Form your own ideas and just make decisions on stable grounds based on numbers. Numbers can save you in these situations. So if you plan to use Postgres on any environment, always benchmark Postgres prior to production and preferably in a controlled environment. Benchmarking is important for capacity planning, optimization of costs. It is also a fundamental opportunity to generate technical credit that we might find useful later down the line when the Postgres database is in production and we might experience performance variability and open, for example, a support incident. So I was in charge of the 24/7 support at Second Quadrant, and when one of our customers hit a performance issue, there were two possible situations we could find ourselves in. A pleasant one, where we had a measure of performance predictability and clear expectations based on benchmarks of the storage and the database that we had done prior to production, and an unpleasant one, where no benchmarks were done. And when a system is in production, it is too late to run benchmarks, okay? So storage performance can vary. Don't trust the declared values by the supplier, but rather validate them. Measure the database performance. knowing that it depends heavily on the storage, which can be often our bottleneck. So I'm going to share a short story. Not long ago, a customer was complaining with us that Postgres on Kubernetes was low. And it turned out that the underlying persistent volume throughput for sequential reads was 3 megabytes per second. Not kidding, okay, 3 megabytes per second. So there's no way Postgres or anything can run there. So I'd like to share, how everything started in our team. So back then I was head of global support at Second Quadrant, as I anticipated earlier. And our team had been nurturing a very positive team culture based on DevOps, lean, agile principles, values, and so on. We had a solid mindset of exploration and experimentation of new technologies with consistent examples of learning, unlearning, adopting, dropping tools. Our focus were individuals, distributed leadership, and empowerment of people. In August 2019, I was asked by the CEO to devise a plan for the company to enter the Kubernetes market for Postgres. For a few years, we had been looking with lots of interest at what was happening in the space, with periodical conversations with our friends at Zalando, and we were very eager to work on Kubernetes, having already adopted container technologies in all our CI/CD pipelines. For example, we were building packages, testing, and things like that. I remember a few major challenges. First, put ourselves in the shoes of a Kubernetes expert and ask ourselves, what is Postgres missing in Kubernetes? So this was the first one. The second one was, what is Kubernetes missing according to a Postgres expert? Both questions required us to quickly become proficient in Kubernetes. We were perfectly aware that although we were an authority in the Postgres ecosystem, we were nobody in Kubernetes. We targeted CKA certifications and were the first Postgres company to become KCSP. We treated the whole Postgres on Kubernetes thing an emergent problem. And as a result, we adopted the exploration mode with a fail-fast approach. As much as we wanted this to be possible, our mindset was to quickly understand if we had to abandon the project in the shortest possible time. So we know that high availability with Postgres was a problem already solved by other players, but we wanted to target something that nobody had actually tried before. So use dedicated physical worker nodes to run a Postgres instance and see if and how Postgres could run on bare metal Kubernetes. If this had resulted to be impossible, we would have bailed out. Myself and Marco, our colleague Marco Necciarini, we used KubeCon North America in 2019 to validate our hypothesis and decided to briefly participate to the 6 storage group in CNCF. And there I proposed that our team performed some benchmarks using local persistent volumes, which had recently been introduced in Kubernetes 1.14, but on bare metal. We ran it. Francesco, he was the leader of that project. Okay, so we had our own bare metal Kubernetes cluster in the Hetzner cloud. We ran our storage tests and results were, let's say, more than encouraging. That was the answer we were seeking, and we decided to proceed. Our results on storage were published on a blog article, which actually became quite popular in the data storage communities in Kubernetes. We use commodity hardware with dedicated local SSD storage, very simple setup to this with hardware RAID controller, and perform storage benchmarks directly on Linux and then inside Kubernetes using FIO. We use the OpenEBS local persistent volumes, and results in terms of sequential reads and writes were almost identical to bare metal ones. We then proceeded with benchmarking Postgres, and results follow the same pattern of storage with comparable behavior to bare metal. In the meantime, the acquisition process of Second Quadrant from EDB had started, and we had to pause our activities. Actually, I think I was supposed to be probably number 1 or number 2 webinar in this data on Kubernetes community. So I'm really happy to be finally here. Okay.
And we are too. Yes.
So we then resumed the work after the acquisition was completed in October, and here we are. So let's now look at what capabilities the database expects from the underlying storage. We all expect it to be available, scalable, that it performs well and guarantees both consistency and durability. So traditionally, Postgres administrators associate availability of the storage with that of the hosting operating system. And scalability is achieved either via table spaces, LVM, or storage online resizing. As a result, when it comes to Postgres, we focus primarily on performance, one of the major sources of support requests, consistency, and durability. So fortunately, when it comes to storage access patterns, the same concepts as in VM and bare metal are still valid in Kubernetes. We just need to integrate all we know with how Kubernetes manages storage, like storage classes, persistent volumes, PVCs, and so on. There are primarily 2 methods of access to storage. The first one is via network, either directly or indirectly. Think, for example, of an NFS volume. Network storage is certainly the most used pattern in Kubernetes, and there's a labyrinth of available solutions, either outside the Kubernetes cluster or inside the Kubernetes cluster. And replication is normally at file system level. Network storage in Kubernetes presents the same issues of throughput and latency that we experience in every other environment. The second method is storage that is local to the Kubernetes node where a pod is running. This also includes a DAS or directly attached disk that database people love. But this is historically an anti-pattern in Kubernetes. We see this is changing, and we hope that the shared nothing architecture for databases becomes more common in the Kubernetes space. Because shared nothing architecture brings performance predictability, even though it comes at a cost. The cost is harder scalability, okay? But Postgres has other ways to do this. So high availability is delegated to Postgres, where we control durability even down to the database transaction level. So let's now look at some of the critical areas where storage can become the bottleneck of a database management system like Postgres. A disclaimer first. This slide offers a simplified view of how Postgres interacts with storage. Let's start with transaction logs, which in Postgres are called write-ahead logs or WALs. They're the most important asset for Postgres when it comes to business continuity capabilities, as they form the foundation of crash recovery, point-in-time recovery, and replication. Briefly, WALs, the WAL is a sequentially written logical file, normally made up by separate files that are up to 16 megabytes of size each. They contain the history of changes that happen to a database. And we need to make sure that the information is written prior to changing an actual page in the buffer. Hence, we request that the change is f-synced to disk to survive from a crash or a sudden loss of power that would wipe the content of any intermediate cache between the disk and the database. When we add a record to a table or modify its content, the change is first stored in the WAL, and then subsequently in the shared buffers for faster access and retrieval of data. These buffers become dirty when the page, which is normally 8 kilobytes, is modified in memory, and the content differs from the actual content on disk. They are cleaned, meaning that the version in memory matches the one on disk after 3 events. The first one is checkpoints. They are normally issued based on timeout, but also on the amount of changes since the last checkpoint, or even manually. Typically, writes for buffer flushing are spread between 2 checkpoints, so to avoid spikes in write operations. The second is by the background writer. And the third mode is by an actual backend process. Backend process is a query that needs to write data, but finds the buffer full. If page spilling becomes the norm, the database is operating in anaerobic mode, meaning that it is obviously not configured or sized properly. So we need to take actions here. For buffer cleaning, we need to look at random writes performance. Also, the OS cache might play an important role here, but that's another different topic, okay? Every time a page is required by a process for a query, and it is not present in the buffer, Postgres needs to fetch that page from disk. And this is valid not only for tables, but also for indexes. And in this case, random read is important. However, random reads are not always as fast as sequential reads. So the Postgres planner is smart enough to realize that based on statistics, if you are fetching a good portion of a relation, it is faster to sequentially read the whole table, for example. This is a common pattern in data warehouse workloads. And in such cases, sequential reads performance become critical. So to recap, based on our experience, when preparing a system for database usage, we should benchmark the storage and determine the throughput for sequential reads, writes, as well as random reads and writes. And another aspect that we need to consider, especially if we are in cloud environments, is the number of input and output operations per second, which might be capped in some cases, but they eventually impact the throughput. But it's something we should keep in mind. So how to measure the storage? Our solution is to use one of the most used tools for this, which is FIO. In the past, we used also Boni++, and it's an open source tool. It's highly configurable, and it's supported also on Kubernetes. And it supports several, I/O workloads, but we'll see that later. So an old saying in our team says, slow storage typically produces slow databases, unless their access pattern is primarily in memory, of course. So we've seen how to benchmark the storage. Now let's talk about the most common workloads in Postgres. So one of them is in memory. So it means that the database fits entirely in the database buffers. So it's primarily bound to CPU and memory. The most typical usage pattern is OLTP, which means that we have many small and concurrent transactions that are a mix of inserts, updates, and reads. And the third one is for BI, data warehousing, and it uses historical databases for reporting, and it's the online analytical processing. Fewer queries, more complex, and that required to read a very good portion of time series, time data. So in our initiative is focused primarily on OLTP workloads where the database size is larger than the available RAM. So the database doesn't fit in memory, forcing us to rely on disk operations so that we can actually see how the storage impacts the database. And what we want to measure are transactions per second. We selected Pgbench, which is the default benchmarking tool in Postgres. It's distributed with Postgres. It's got it ships a simulate a TPC-B-like workload, which is an online transactional processing workload. It's highly configurable. And so at the moment in our initial experiments, we are using the standard queries, but we could also inject our own queries, custom queries to simulate different workloads. Also in the future, we want to add also application level testing so that we could use a pool, for example, a replica deployment of web applications with hey in front that generates a random web access. So now, Francesco, I leave it up to you. So do you want to share?
Thank you. Yeah, maybe it will be easier for me, but I cannot share while you are sharing.
Okay, so I'll stop sharing and I'll stop sharing, Francesco.
Yeah.
Okay,
Yeah.
thanks.
Thank you. And this is it. Oh, you should be able to see. Uh, so what we did to have a sort of standard way to test, to get benchmarks on cloud native Postgres was developing a tool called Pgbench. So what is Pgbench? Well, Pgbench is a collection of Helm charts. That means that it will be quite easy to run and customize, and the result will be easy to reproduce. We wanted to have something that could be used in the beginning of Kubernetes journey. So someone with Postgres experience starting working on Kubernetes could easily use an Helm chart and customize it. So we have decided to use the tool that Gabriele was talking before, FIO and Pgbench, to monitor the IOPS and transactions per second that we could get from a certain setup. The code is available on GitHub, so if you go on github.com and repair DBC and Pgbench, you will be able to get the codes and test it for yourself. So we have two charts, one for the FIO benchmark that is used to benchmark the storage. So what is done in this by this chart is creating a PVC, and you can customize it. You can choose the storage class to get the PVC from. You can choose the size of the PVC. Then the FIO chart will create a config map containing the FIO job, which is not a Kubernetes job, is how FIO should run a workload. And then it deploys a pod with FIO running the benchmark and serving the results on a web server when we are done. So this is the values.yaml, so it's really simple. You can see that the first part refers to the PVC, and then there are information about the FIO job that we want to run. And then after the run, you get the results, you get the bandwidth, you get the IOPS from the test. So for example, here, this was a run performed on a kind cluster running on my laptop. And I know that, well, my laptop is able to run at about 135 megabytes per second. Then, similarly, we have a Helm chart for Pgbench, which starts a cloud-native Postgres cluster. And of course, again, you can customize it in the Helm chart because, of course, different Postgres settings can give different performance. Then you define the Pgbench job to run. This one is a Kubernetes job as well. And again, you can define the size of the database you want to create and the amount of connections that Pgbench will perform. At the end, you can get the logs of the Pgbench pod and see what is happening. So here there is again a small values.yaml for Helm with the full configuration. So, and again, first half is dedicated to the Postgres configuration, and the second half is Pgbench. We also use node selectors to avoid Pgbench jobs from running on the same nodes as Postgres pods, so they don't affect each other if that could happen. And then in the end, you get the logs and you get the amount of transaction per second that you can get on the system you have run the chart on. So with this, we have decided to actually run some tests on the cloud, and we have started our tests on Azure. So we wanted to see how the network storage on Azure was performing. So we have tested a few combination of VMs and disks. Of course, there are when you go to the cloud, on public cloud, there are all sorts of complexities because you have to decide the size of the VM, and the size of the VM could not only define the amount of CPUs that you have or how many gigabytes of RAM you have. Different VM families can have different limits. So for example, you can have VMs that limit IOPS on the underlying storage. And then you have the storage itself. So you can have, again, different storages with different limits. And some disks allow you to go over the limit for some short amount of time. So it's called burst. It's usually available for lower size of disks on AKS. So in the end, we have gathered a bit more results, but this one were the most complete. So we have used a standard E8 DV4 VM for this to gather these results. It has 8 CPUs, 64 gigabytes of RAM. It has a defined amount of bandwidth. It's 4 gigabit per second. We have tested it with different storages. They are all premium disks from Azure. The speed of the disk in Azure is tied to the size. The larger the disk, the faster it should be able to go. So a smaller P10 disk, it's just 100 gigabyte. It can offer you 500 IOPS. A larger one, you can get to up to 20,000. So with these things that are documented on the Azure website, in the Azure DoK, we decided to test. We have chosen to run our test for 1 hour, and on FreeIO, we chose to use a block size of 8 kilobyte. This is because it's the one that Postgres uses. And well, we can see that globally, the fastest disk is usually better. And we can see that choosing the 8 kilobyte blocks, our operation are mostly capped by IOPS. We never reach the amount of bandwidth that the disks have. We usually go at the IOPS level, but there are some oddities in here. So for example, the P10 looks like it has very, very, very high read speed. And then also the P30 here is going way over its limit, while the P80 never reaches the limit. So you have to get familiar with the hardware you get. There are explanations for this. They're all documented. So for example, I said before, some disks, use the small disk, have a burst. So while on average, we are way over the 500 IOPS that we have as a cap, what actually happens is that for the first half an hour, we are running at the burst speed of 3,500, and then we have the declared 500 IOPS. So if you look at this and you can't decide that your database, since the average is around 2000, it will run at 2000. It will usually run at 500 IOPS. That could be fine if your database is small, but that's probably not for larger DB. Then, why did we have this way higher reads? Well, the disks have a read cache. If you try to run the same tests without the read cache, the results are more in line. So there are P10, no cache. Again, you drop down from 483 megabytes per second to 16. What happens? Well, happens that the cache of the disk is larger than the disk itself and of the file that we are writing. We were writing files large, almost as the disk. So, of course, running the same test over and over again, the data would go in cache, and you would get these results that had no sense. Well, read cache is good for database, so don't go disabling it, but it's nice to see that there is an explanation for that sort of result. And for example, in the documentation, there is no information about the cache on this machine, but there is the sister machine is not the E8D, but the E8DS that says it has 200 gigabytes of cache. That would explain this behavior very easily. And the same sister machine has a cap on the disk IOPS around 12,000. So this could also explain why we can't reach the declared 20,000 IOPS that we are supposed to have from the P80 disk. So this means that when you go and try what's going on your disk, you can get different results according to the full environment. So you need to know what you're running on, especially if you know what are your requirements for the database. And then on the database size, we have tested Pgbench. Well, we have defined different database size on different disks because the disks were one larger than the other. And so a small DB database on a small disk or a large one on a larger one, but faster, they mostly have speed, that amount of transaction per second that can be satisfying. Over 1,000 transactions is good for a medium database. The configuration of Postgres was mostly default. We have changed a few parameters to get better results from a machine with 64 gigabyte of RAM. So we have raised a bit shared buffer. We have raised maximum size to not checkpoint too much. But then the results were good in the end. And then we have tested network storage. What about local storage? The idea is it should be faster. It's directly on the machine. So we have tested the L8S machine. That is the family of machine that comes with an NVMe disk. And well, the results were way better. Way in terms of row speed, then it's tenfold increase. In terms of transaction per seconds, it's twice as fast. So this gets back to the initial idea that local storage for database is an interesting point. And yeah, thank you. I let Gabriele draw the conclusions, and I'll stop sharing.
Thanks, Francesco. If you can move slide.
Yeah, okay.
Thanks.
I'll lead the slides.
So, yeah, so thanks. I mean, this is the end of the talk. I mean, the key takeaways, these are the main three takeaways. So provide a methodology for benchmarking Postgres database in Kubernetes, an open source set of tools, and go through the reasons why Kubernetes for databases is a valid option, and Postgres is a valid option, and also why benchmarking is important. Once again, even in the QR code, there's a link to Pgbench, which is basically announced tonight. And we hope you enjoy that. And feel free to reach out to us in the Data on Kubernetes chat and to test our software. Okay, you will hear more from us in the next weeks and months. And the last one is, before the questions, we're hiring. So if you want to work with us, please, follow that URL. So we need people to work in our team. So yeah, that's all. Bart, up to you.
Yeah, I mean, just following on the hiring factor, not many people have companies where someone can lose a tooth and give a meetup afterwards. So keep that in mind. I think that should be, I think that's a pretty strong, it makes a pretty strong case that you'll be working with some very talented people that not only work with, technologies that are auto-healing, but themselves are auto-healing. So I think it's quite impressive. That being said, in terms of questions, Gabriele, I passed you some of the questions that we had, but if not, if you want to maybe just answer one, and then the others we can get to in Slack.
Yeah, I think I can pick, there's one question. What considerations should we take into account when running highly available Postgres? Okay, so in my opinion, shared nothing architecture is fundamental. So shared nothing means to distribute Postgres instances across different Kubernetes nodes, possibly dedicated nodes to a single instance, and use dedicated storage to the node, which is possibly local to that node, as I explained before, for performance predictability. Okay, but availability alone is not enough. You also need disaster recovery capability for business continuity, and Postgres supports continuous backup and point-in-time recovery, which are critical for this enterprise level database context. Instances can be spread across different zones in the same Kubernetes clusters. And we are also working as EDB on the cross-cluster replication for Postgres, which is expected later this year. And briefly, there's another question about what are the advantages of using an operator over installing the database the old-fashioned way. I mean, the operator, and that depends on the operator. I can talk, about hours, for example. The container approach only provides self-healing capabilities. Then replication, availability is all delegated to the file system level. An operator provides a higher level experience. So with native streaming replication support, for example, and this includes also synchronous replication. There's automated failovers, planned switchover, rolling updates, scaling of read operations, transparent management of TLS. I could go on, with this. So I think it's a more. Postgres is a complex application, and I think an operator is what we need when we have to manage complex applications or workloads. So thanks. We'll reply to the questions in the chat if I think we're running over.
Yeah, it's okay. No, it's good. And anyway, we had to improvise a little bit, so it's no big deal. Gabriele, can I get you to stop sharing your screen? Or I don't know if it's you or sharing your screen.
That's Francesco.
Okay, San Francisco. Okay, cool. Let's see, because we always have the final part of our meetups, which is quite a lot of fun. I also did post a link in YouTube for the Postgres workshop that Alvaro will be doing on the 29th of June, so you can sign up for that. It'll be a hands-on kind of affair. But anyway, we have a bit of a tradition. So talking about improvisation, as Francesco very much improvised today, I can't imagine, because for me it'd be the same thing if I had to give a talk in Spanish with a missing tooth, like having to do it in another language. Anyway, now, so we have a wonderful artist in our community, Angel, who's always present in our meetups. And so I think you can see my screen now. So while you've been talking, Angel created a visual representation. Can you see my screen now? I think so.
Oh, I love that.
Okay, good, because we even got, he even was able to get Francesco with a t-shirt with a missing tooth. And we got a little bit of a shout out to AC/DC on Gabriele's t-shirt. Angel is also a musician, so anyway, I think he did a pretty good job. We'll be sharing that on Twitter and also on LinkedIn and our Slack. Thank you very, very much for this wonderful meetup. As once again, as Gabriele started out in the beginning, starting with why is a really important part from our community. I think that's like an additional takeaway in all of this is why are we going to do this? You're going to meet some resistance from customers that might, as you mentioned, in terms of speed or might have other difficulties or issues. But when you understand the why from the beginning, a lot of the other things, I think you can treat it with a little bit more patience. So I think this was phenomenal. It's also nice as what you said as well, Gabriele, that you were supposed to be doing one of the first meetups in our community, which was, last year in July. So it's good to have you with us now, and I'm sure we'll be seeing you again. Remember that EDB is hiring. We'll put the jobs as well too in our job section in our Slack. Just as a reminder, if you would like to find out more about that, I'm sure you can just talk to Gabriele or Francesco directly. But that being said, thank you both very, very much for spending some time with us today. And Gabriele, get some good gelato or something cold, or I don't know what you got to do, but take care of your teeth, man. Okay.
Good. Thank you very much.
Thanks a lot. You guys have a good one. Ciao. Take care. Bye-bye.
Thanks. Bye-bye.
Bye-bye.
Record.